second cycle experiment is Sonochemical Reactor. So Sonochemical Reactor basically, here in this case, so there will be ultrasonic waves that are produced at a frequency of 20 kilohertz. So due to this frequency, so there will be a vibration that is created inside the reactor and the samples gets mixed up. So and there will be a reaction taking place between sodium hydroxide and ethyl acetate. So here we will be carrying out a second order reaction between sodium hydroxide and ethyl acetate, which is a saponification reaction. So in this setup, first initially, so we need to fill water and we need to place the beaker at the center. So and the lid will be closed. Once the setup is arranged, so the lid will be closed and the experiment will be started. So at a different time intervals, so at an interval of 3, 6, 9, 12, 15 and 18 minutes, so we'll be collecting the samples, so and we'll be making the titrations. So for that we need to see the preparation of solution. So in the preparation of solution, we'll be preparing 4 different solutions. That is 0.1 normal of sodium hydroxide, 0.1 normal ethyl acetate, 0.1 normal HCl, so and 0.1 normal oxalic acid. So the preparation of 0.1 normal of all these samples are shown in the first 2 experiments, that is in the plug flow reactor and the mixed flow reactor. The same procedure is followed here also, but we will be preparing about 500 ml of the sample, only 500 ml. So once the solution is prepared, so we need to standardize. So to make the standardization, we will be standardizing sodium hydroxide using oxalic acid. So sodium hydroxide will be taken in the burette, so the oxalic acid is taken in the conical flask, so and the indicator used is phenolphthalein. So after standardizing sodium hydroxide, we need to standardize hydrochloric acid solution. So hydrochloric acid solution is standardized using the standardized value of sodium hydroxide. That is by taking sodium hydroxide in the burette, so and 10 ml of HCl in the conical flask. So after the standardization is completed, so we will be taking a 100 ml burette. So to that 100 ml of burette, so we will be transferring 25 ml of sodium hydroxide, so and 75 ml of ethyl acetate. So once those two are mixed, so it is placed inside the reactor. So initially the reactor will be filled with water. So after filling it with water, we need to place the burette beaker. So after the beaker is placed, so we need to close the lid. So and we need to turn on the sonochemical reactor. So we need to collect the samples at different time intervals. So the time intervals can be measured by varying the time here. So you can see 1 minute, 2 minutes and 3 minutes. So we will be varying at an interval of 3 minutes up to 18 minutes. So I will be collecting about 6 samples at different time intervals and we will be putting out 10 ml of this mixture and we will be transferring it to a conical flask that containing HCl. Because the role of HCl here also is to arrest the reaction between sodium hydroxide and ethyl acetate. Once the reaction is arrested, so we need to titrate this mixture against sodium hydroxide, which is taken already in the burette. So the end point will be colorless to pale pink. So the same experimental procedure is repeated for different time intervals. After the experimentation is completed, so in the sonochemical reactor experiment, so first thing is the standardization of NaOH. So N1, which is equal to 0.1 normal, which is the oxalic acid normality, V1 which is equal to 10 ml, which is the oxalic acid volume, V2 is the volume of NaOH rendered in the burette, and we get the normality, N2 which is equal to N1 V1 divided by V2, so we get a normality. Still the standardization of HCl. So V3 which is equal to 10 ml, that is volume of HCl taken in the conical flask. V4 is the volume of NaOH rendered in the burette, so we get the normality N3 is equal to N2 into V4 divided by V3, so we get normality. So after the standardization is completed, we need to go for observation. So we will be conducting the experiment for different time intervals, that is starting from 3 minutes to 24 minutes. So we need to note down the timings. So after noting down the timings, we need to calculate the value of concentration. So concentration which is equal to N2, that is normality of NaOH into V4. V4 is nothing but volume of NaOH rendered during HCl standardization minus V5. V5 is the burette reading. So divided by 10. So we get the values of concentration. So after calculating the values of concentration, we go for plotting of graph. So the first graph will be concentration versus time. So when we plot a graph, so we get the nature of the graph as a curve. So after plotting the curve, so we need to calculate the slopes. So by drawing the tangents at different points. So we need to draw totally 5 different tangents. So we get the values of the first slope, second slope and third slope, which gives you the value of minus dCA by dt. So tabulate these values. So which are nothing but the minus RA values are nothing but rate values. So after calculating this, so we need to calculate the values of ln of minus RA and ln of CA, that is natural logarithm of rate values versus natural logarithm of concentration values. So after calculating the rate values and concentration values, so we need to plot a graph of ln of minus RA versus ln of CA. So we get a straight line with some intercept. So the intercept will be equal to ln of k and the slope gives you the value of n. So if you see the equation, so we know minus RA is equal to k into CA to the power n. So if you take natural logarithm on both the sides, so this will be ln of minus RA, which is equal to ln k plus ln of CA. So which is of the form y is equal to c plus m into x, where your c is the intercept and n is nothing but the slope.